Hello everyone, this is lesson 5.1, Midsegments and Triangles. Today you're going to learn how to use properties of midsegments and triangles to solve problems. So a midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. Every triangle has three midsegments. So here, point M is a midsegment, or point M is a midpoint, point P is a midpoint, and point N is a midpoint, because it divides each of the sides of the triangle into two congruent segments. Therefore, MP is a midsegment, PN is a midsegment, and NM is a midsegment. What segments are congruent by definition of a midpoint? So we have AM is congruent to MB, BP is congruent to PC, and AN is congruent to NC. Study the midsegment below. Now, what segments are congruent? So in order to understand this question, one thing we have to learn about is similarity, which we will learn in another chapter. But just a brief concept of that. So if you consider the entire triangle A, B, C, this entire segment, or this entire triangle, and then you consider triangle AMN. So if in order to be a similar triangle, these side lengths have to be proportional. And just like there are shortcuts to proving that triangles are congruent, there are also shortcuts to proving that triangles are similar. One of those is side angle side similarity. So the one squiggle says that the triangles are similar rather than being congruent. So if you know two sides are proportional and the angle in between them is congruent, then the triangles are similar. So that means if you have triangle ABC and triangle AMN, two sides are 1/2 of the length of two sides of these triangles, and the angle that's included is one that they both share. So we know that that angle A is congruent to angle A in the smaller triangle. Then we know that the larger triangle is proportional, so it's similar to the smaller triangle. And then there's something called CP/CTC with similarity. Corresponding parts of similar triangles are similar. So then we know that MN is also 1/2 of the length of BC. Therefore, we could give MN one tick mark. So if you look around the triangle, the other midsegments also would get the corresponding number of tick marks from the opposite sides. So PMP would have 3 tick marks because it's congruent to AN and NC. And then this midsegment would be congruent to both of these. So that gets 2 midsegments. So here you could say MN is congruent to BP, which is congruent to PC. And also, we'll go with NP next, is congruent to AM, and that's congruent to MB. And then for the last one, MP is congruent to AN, and as it is congruent to NC. So this brings us to the midsegment theorem. It says the segment connecting the midpoints of two sides of a triangle is parallel, so we'll talk about that in a second, to the third side, and has a length that is 1/2 that third side. So a midsegment is always parallel to the opposite side and 1/2 of the length. So DE is parallel to AC, and DE is, if we're comparing it to AC, is 1/2 of AC, or 2 times DE is equal to AC, depending on what you are given. So if you look back up here, you would have corresponding angles, since you know that angle BMP would be congruent to angle MAN, because those two would be corresponding in between the 2 and the 3 tick marks. Since those corresponding angles are congruent, then the lines are parallel. That's the converse, corresponding angles converse theorem. So let's do some practice. So if triangle ABC has vertices 0, 2, 2, 10, and 12, 0, we're going to find the midpoint of D. So let's go ahead and graph the triangle. So A would be 0, 2. And then B is 2, 10. And C is 12, 0. So it's number 1 says to find the midpoint D of AB. So we're going to find the midpoint of AB. So we can use our midpoint formula, or you can just look at your graph. So if this is going up 8 and over 2, that means the midpoint will be up 4 and over 1. So here at 1, 6. Okay, and then D says show, oh, and we also have to find E. Sorry. So E of BC. So here we're going down 10 over 10. So the midpoint will be down 5 over 5. 1, 2, 3, 4, 5. So I just didn't graph this very accurately because I had to extend the line. And then we can draw, so that would be at 7, 5. We can call this, oh, this is D and this is E. And then we can construct the midpoint, or the midsegment. Then show that DE is parallel to AC, so you would just find the slope. So the slope of DE, you're going down 1 and over from 1 to 7, so down 1 over 6. And then AC is also down 2 over 12, so that's down negative 1, 6. So since the slopes are the same, then they are parallel. And then show that twice of DE equals AC. So for this question, you would have to use the distance formula. So here I'm going to find the distance between D and E. So we'll do subtract the x's. So 7 minus 1 squared plus 5 minus 6 squared. If you simplify, that would be 36 plus 1, which is the square root of 37. And then we can approximate that. As 6.08. So there's our first distance. Our second distance, we're using AC, so A to C. So for that one, you're doing 12 minus 0, which is 144 squared, if you square 12, and then 2 squared, which is 4, and that is the square root of 148. Now, something to keep in mind is, you see how we got the square root of 37 here? 37 is not twice of 148, because this is in a square root. Once we get it out of the square root, then they should be, so if you do the square root of 148, that'd be 12.16. So if we don't round up, then we can see that they are the same. Okay. So here are some practice problems. So this is DE is a midsegment, find the value of x. So for this one, x would be twice the length of the midsegment. So here x is 7. With this one, x is equal to 8 because this is a midsegment, so E is a midpoint. And here x would be half the length, so 17. Okay, these questions, they're all related to this triangle. It says if DE is 4x plus 5, 4x plus 5, and GJ, so the entire thing is 2x plus 25, then find DE. So for this question, you would take GE, or 2 times the length of DE, and set that equal to GJ. Or you could do DE equals 1/2 of GJ, but I would prefer to do the 2 in this case. So 2 times 4x plus 5 equals 3x plus 25. So if you simplify, you would get 8x plus 10 equals 3x plus 25. Move terms over and get 5x equals 15, so x equals 3. Then we're finding the length of DE, so you would plug that back in for your x. So 4 times 3 is 12, and 12 plus 5 is 17. So 17 will be your final answer. For number 5, it says EF is 2x plus 7, and GH is 5x minus 1. What is EF? So I'm not going to bore you in solving these, but we can just set it up. It'd be the same setup. And then you would solve for x and plug it back in. For number 6, it says HJ is 8x minus 2. So here HJ is this entire length, and DF is 2x plus 11. So once again, this is the same idea. We're doing 2 times DF equals HJ. And then for 7, it says, I think 7 is different. HD gives us HD, which is this. And then DG is that. So the reason this is different is because they gave us both of the lengths, and they tell us to find EF, which is congruent to it. So we would set these equal to each other to get x. Move your terms over, so this would be 22 equals hang on. Oh, sorry, 11x, and x is 2. Then you would plug 2 back into either of these. So I'm just going to pick this one. So 3 times 2 plus 29 would be 6 plus 29, which is 35. Okay, so that concludes this lesson, and now you can work on your homework. Thank you and have a great day.